I'm going to do is 2012 question 10b. It says define an acid in terms of Bronsted-Lowry. So a Bronsted-Lowry acid is one that is a proton donor. And it asks me then, what is a conjugate pair? So a conjugate pair, that's two substances that differ by a proton. Then it gives me a certain water-soluble acid, so it gives me an indicator. It says this is a weak acid indicator and it dissociates as follows. So it dissociates in solution into H plus and In minus. The HIN, the undissociated form, is green and the dissociated bit is purple. And it asks, state and explain. So state and explain the colour observed when you add 0.5 molar NaOH solution. So if you put a few drops of the solution of the indicator into this, what will happen? Put that indicator into this solution. Okay, so your NaOH, of course, is made up of Na and OH minus ions. So explain what happens, explain the colour change and explain why it happens. So first of all, number one, the OH minus from the base reacts with the H pluses from the indicator to form water, which means that the H plus concentration decreases. The H plus concentration here decreases. Now you'll notice, look, it's a double-headed arrow, so it's an equilibrium equation. Now, according to Le Chatelier's principle states that if you stress a system, it shifts to alleviate that stress. So according to Le Chatelier's principle, a system shifts to alleviate a stress. Shifts to alleviate stress. So the stress here is that you've added, or you've removed H pluses. So the system will shift to alleviate the stress and it will move to produce H plus ions to replace those that have been removed. Okay, so what happens then? So the reaction moves to the right. So the reaction moves in the forward direction. And what do we see? A purple colour is seen. And that's your explanation. Now you do the opposite. If you added an acid, if you added H pluses, you'd stress the right. So it would shift, according to Le Chatelier's principle, to alleviate that stress, and you'd see green. So you'd explain either way, whichever one's more appropriate. Right, next bit. Calculate the pH of a 0.5 molar NaOH solution. So you've got a 0.5 molar NaOH solution. So NaOH, of course, splits up into Na plus OH minus. So 1 mole of NaOH gives you 1 mole of OH minus. 0.5 moles of NaOH will give you 0.5 moles of OH minus. So we're going to find the pOH, of course. So the pOH is minus the log of the OH minus concentration, which in this case is minus the log of 0.5. When you put that into your calculator, you will get a pOH of 0.301, which means your pH is 14 minus 0.301. And this gives you 13.699. The second part of that question, the last part, asks you to find the pH of, so this one we want the pH of a 0.1 molar solution of this indicator. So 0.1 molar solution of the indicator, given that its Ka is 2 by 10 to the minus 5. Okay, so that's a nice straightforward one. The pH is equal to minus the log of course, the square root of Ka by molarity. If you're given a Ka, use it. So minus the log of the square root of 2 by 10 to the minus 5 multiplied by 0.1. So that will give me minus the log of the square root of 2 by 10, 2.5 by 10 to the minus 6. And then when I put that into my calculator, I'll get minus the log of 1.581, which gives me a pH of 2.8.